Okay, ladies and gentlemen, let's start talking about volumes. Now, volume is the amount of stuff inside. So, for example, I have a measuring cup right here. This measuring cup has water in it. Okay, so here we go, guys. Markings down the side here. And we'll take a look here. Whoa, Pyrex, there we go. So you have measurements right down the side of that. That's going to be volume. There's a certain amount of water in here. If I had food coloring, I'd put food coloring in it. But I also don't want purple water spilled on my computer. So we'll go with clear water today. So volume. Now, we also have things in terms of solids that are a volume. Now, this right here is a block of wood. It is indeed a square cube of wood. Okay. Ideally, we would have used 1 inch by 1 inch by 1 inch, but I happen to have 3/4 by 3/4 by 3/4 from another thing I was doing. So I took that 3/4 and I put it in the saw and chopped it up into pieces. So there we go. Right there, I have 4 cubic units. Now, it's a cubic unit because this is 1 unit wide. It is 1 unit long. Here we go, 1 unit. And it would therefore also be 1 unit tall. So there we go. I have 1 unit by 1 unit by 1 unit, all right there. So this would be the basis of my volume. Volume is going to be measured in units cubed. Now, it could be cubic centimeters, cubic inches, cubic feet, cubic miles. Doesn't matter. If you think about it, cubic miles of air pressing down on you right now. So think about that. So that's 1 cube. Now, volume for prisms, which is what this is a prism, okay? And this happens to be a right prism where I have a right angle, a 90-degree angle right here. So the base and the height meet at a 90-degree angle. So that's a nice right prism. As an example, this is a right cylinder, okay? The base and the sides meet at a right angle. So that works out nicely. This is an example of not a right cylinder. You'll notice this has off at an angle. So this angle right here is not straight, and it makes sense. So if I stand this one up and I stand this one up, well, let's take a look at them again. If I take a look at them, one definitively stands up straight, the other one does not stand up straight. So right prism, oblique prism. So let's go ahead and put those down. Let's call that a right prism, and this is an oblique prism. Okay. By the way, while we're at it, let's talk about cross section. Cross section is the shape that you would get if you cut across a figure. Now, you can cut across a figure in any number of ways, but let's take a look at our oblique and our right cylinder just as an example of how it's different. Now, obviously, I had a dowel rod, and that dowel rod I took and I put it out on my saw and I chopped it. So I chopped it right there, cut it in pieces, and I made cross sections. And so this cross section and this cross section, because they match, they're both circles. And in fact, if you take a look, this is a circle. This, on the other hand, I had to cut at an angle. So what I did was I cut it at an angle, boom, just like this. And these cross sections, although kind of circular, you'll notice they are longer than they are tall. So if I give you a comparison, I have a circle and I have something that's not a circle. Well, in that case, it's an ellipse. Now, an oblique is going to have a cross section that's not a circle. You'll notice this one isn't very oblique, so its lengthening isn't quite as obvious compared to this oblique, which is very obvious. So I really get it going crazy over here. So cross sections. So you have right, you have oblique, okay, or you could have something that is super duper oblique like this, okay? So by the way, this is right, that's oblique, and now I have a compound shape that is both. So we'll have to deal with that later. So we have right and oblique. Now, this is a right prism, and a right prism would look like this. Your standard cube that you're used to. Oblique would look like this. And it would be off to the side. So instead of standing up straight like this one does, it's actually going to, this one's actually going to be off to the side. Now, so you have right and oblique. So for volume, it doesn't really make a huge difference because it's always going to be base times height. Base times height. Now, in the case of my cube, my base is a square. So I could say, instead of just base times height, I could say length times width because it's a square. And then say height. In the case of my cylinder, so this is a prism. In this case, this is a cylinder. That's going to be a little different. That's going to be pi r squared times h, because the area of a circle, if that's my radius, pi r squared is going to be my area for this whole base. That's my whole area. So take a look. If you see that, you kind of get the idea of where we're aiming for here. Now, so this is all good, but let's think about volume in terms of how much space it takes up. In terms of how much space it takes up, this is currently 1 unit cube. But if I put two of them next to each other, and then let's get crazy. Let's actually put all these together. And I'm making a bigger prism. And in this case, the prism is going to be, there we go. The prism is going to be 3 units long, and it's going to be 2 units tall. Okay, 3 units long, 2 units deep, I guess, technically. And it is clearly 2 units tall. So I have 3 by 2 by 2. And in fact, 3 by 2 by 2, if I were to draw a picture of this, there we go. 3 by 2 by 2. I have a volume that's going to be 3 by 2 by 2. Answer is 12 units cubed. And you say, I don't believe you. Well, believe it, because here we go. I see 6 blocks right here. 1, 2, 3, 4, 5, 6. Let's put them over here. I see 6 blocks right here. 1, 2, 3, 4, 5, 6. Together, they make that whole block, and so I have 12 cubic units. So 12 cubic units. And that would be my answer for that volume. So for a basic prism, it's just length times width times height. Now, in this case, I could also take my same 6 blocks and I could turn it this way. And you'll notice it's still 2 by 2 by 3 units. But because of the commutative property of multiplication, it all works out and you're still going to get 2 by 2 by 3. So you get that for a volume. Now, remember my measuring container. This is volume. We're going to use this idea here in just a minute. If I take a look at what it's currently measured, my current volume is at just between, it's about 650 milliliters. Okay? 650 milliliters. So if that is the amount that's currently in my measuring glass, one of the other things I can do for volume is I can measure it by displacement. Meaning if I take my 6 blocks, or my 12 blocks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. and I take all those blocks and I submerge them. Now let's see here. I'm going to use a little thing to help me here. I submerge my blocks. Now I'm not submerging the big block. I'm just submerging these blocks. Now if I take a look, the water level has gone up definitively to over 700, or just about 700. By putting the blocks in the water, I've raised the level of the water because every one of those cubes displaces a certain amount of water, and so it allows us to take irregular shapes and measure their volume. Now, won't bore you with the fact, but 1 milliliter equals 1 cubic centimeter. So 1 centimeter by 1 centimeter would be 1 milliliter. So what happened was when I put my blocks in, the water went up to 700 milliliters. So I can say that the volume of these 12 blocks is approximately 100 milliliters. And that's the volume change. So volume is the space inside something, or in this case, the amount that the volume displaces. And so in this case, we can either measure it with a formula, base times width times height, or we can do it by displacement for measuring its volume. So that is volume for a prism.